taking glucose from products that are available. For example, maybe some fatty acids, maybe some amino acids. So the goal is for the release of this hormone so that it can tell the liver, release what you have available into the glucose form so that the blood levels can rise until this person eats again. And hopefully the gut-brain peptides are working correctly, and you're going to get those little pangs of hunger, you know, about 4 to 5 hours after you eat, and your stomach's going to kind of go, "Rrr," and you'll be like, and you'll keep doing what you're doing. Then all of a sudden, you're like, "Oh, I'm hungry." Hopefully, you're going to go eat lunch. And the process starts over. You've given it foodstuffs. It'll use them. Goal, balance until we eat dinner. Isn't that cool? Under normal conditions. Woo boy, do things go wrong. Just saying. Okay? The beta cells, they're the ones that secrete insulin. What we associate, okay, we get these blue, all right, what we associate with that disorder, diabetes, okay. The sad part about that, like type 1, there are many things that can be going wrong. Type 2, like over 90% of those beta cells can be destroyed or not working properly before you even get diagnosed. Okay, and so the insulin, as we know, okay, it's a multifaceted problem for people who have diabetes. Okay, now insulin is our hormone of nutrient abundance. It is secreted after a meal. It targets liver, skeletal muscle, adipose tissue to absorb glucose, promotes synthesis of glycogen so that we don't have too much in the bloodstream. If we need to, store it, because that is short-term storage. If we need to go to long-term storage, it goes to the fat cells, okay? Now, synthesis of protein, well, we want the body to take those proteins that we've given it, break them down, get the amino acids, get amino acids to the cells, okay? Anything that is an inaction of insulin, we know as diabetes mellitus. Okay?
So what you're describing, this is pretty much insulin dependent.
Now, type 1 is the one labeled insulin dependent.
This is not because the beta cells secrete insulin. So
These are the cells that go wrong. So in other words, if a person has type 1 or type 2 diabetes, these are the cells that are either not producing, production is not enough, or they've been destroyed, such as those with type 2 diabetes. Okay? But note my terminology. Okay? Type 1 and type 2 diabetes, as we know it, okay, that is diabetes mellitus. Because in reality, what does the term diabetes refer to? That's urine. Mellitus lets us know that it's this type 1 or type 2. Okay? So, insulin, like I said, very important. Things go wrong, it becomes a multifaceted problem. Now, amylin. Amylin helps to slow the stomach emptying. What? What exactly would that mean? Why, if I eat a meal, would I need to have control over those contents emptying out of my stomach?
So you get start getting absorbed into the body.
You let it go too quickly, the absorption is not going to occur effectively. So this, if you can have, and plus, it's going to cause the other gut-brain peptides to kick in and make you want to eat again quickly. And so having the control over stomach emptying not only keeps the gut-brain peptides working correctly, but it's also allowing the foodstuffs time to get churned, so to speak, from the chyme of the stomach, begin to make their way through the small intestines. And as they're beginning to make their way through the small intestines, things getting absorbed at a normal rate. So that we are absorbing the carbs at a normal rate, the fats at a normal rate, the proteins at a normal rate, the amino acids, I should say. Does that make sense?
Mm-hmm.
Delta cells, which were just a few, I pointed them out in the picture. The somatostatin, do you guys remember us talking about the growth hormone inhibiting and the glucoses? Okay, and this one also working with helping to slow the stomach emptying so the body can use the products correctly, which is the goal. The next organs are the gonads, the ovaries and the testes. Both of them have an endocrine and an exocrine function. Exocrine meaning to leave, okay, outside. The exocrine products are the egg and the sperm. The endocrine products are the hormones, mostly the steroids. They are regulated by the hormones of that anterior pituitary. You guys remember the LH, FSH? Okay. The ovaries, remember one of the things that I said, for the androgens, estrogen was very minimal, okay? The majority of estrogen up to menopause is from the ovaries. The ovaries secrete estradiol, progesterone, and inhibin. Their goal, work on egg development and get the uterus ready for implantation. So if the egg gets fertilized, that egg has somewhere to go to and begin to develop. The testes, they're made up of the tubules, the seminiferous tubules, okay? They produce sperm. They secrete testosterone, androgens, estrogens, and inhibin. They're working to control the rate of the sperm production. Between the tubes are some cells. Anytime we have cells between cells, and cells like between the tubes and so forth, they're called interstitial, in between cells, okay? Those are the source of the testosterone and the sex steroids. Their goal, function and development of the male reproductive system from the time of development through adult life. And they're acted on by those hormones from the anterior pituitary. Some other tissues and organs that will help with the endocrine system. Your skin. When you all were studying the skin, did y'all talk about cholecalciferol? Okay, so UV light, all right? Where do we get that source? Where does that source come from?
Sun.
The sun, all right? Right now, how much exposure would you say we're getting right now for our skin to the sun? Not a lot, okay? Why is it important for us to get exposure for our skin to the sun's UV rays, which sounds kind of bad because we always think UV bad, UV bad, UV bad, UV bad. Right? Right.
So is that why a lot of those machines are coming out that, go over the face that supposedly gives the UV?
Machine.
It's like an infrared
Oh yeah,
red
the
light.
artificial.
And it's like a little mask, and you just put it over your face, and you have on little glasses, and it's supposed to give you the UV. A lot of estheticians and stuff like that, dermatologists use them,
Well,
which I can understand because to me it's not the same.
But we
light.
cannot get the vitamin D from that.
that's not something I'm familiar with, but I'm going to have to look that up. But yes, the importance of the UV with the skin and the cholecalciferol, then with the help of the liver or the kidneys, convert it to calcitriol, vitamin D. Vitamin D helps with this. So if you get your vitamin D, you get the UV light, with the help of the kidneys and the livers, you get your calcitriol, which will help calcium levels. So right now, I'm betting for the majority of us in here, if we were to go have our vitamin D levels checked, chances are our vitamin D would be very low. Okay? Because we don't have a whole bunch of our skin exposed to the sunlight. How much exposure do we have to have per day for it to be functioning correctly?
15 minutes.
15 minutes. So they keep going, UV bad, UV bad, UV bad. You need 15 minutes of it. Okay? With as much skin exposed as possible. Okay? That's up to you. All right? That's your choice. But what I'm saying, vitamin D is important in the body. The liver, man. To even begin to think about this organ is mind-blowing. We know of at least 5 hormones just in the endocrine system from the liver, okay? The liver, because it does so much, it is hard to put the liver into just one. It needs to be just an organ by itself. It needs to be an organ system by itself, okay? It's usually lumped into the digestive system, but trust me, it's way more than that. Cholecalciferol, skin. Angiotensin, raw system, okay? Erythropoietin, which we'll learn about with the kidneys. IGFs, which we'll get to, well, we kind of talked about those this chapter, and growth hormones. Hepcidin, holy cow. I mean, just the iron, for example, which we'll get into when we start talking about the the blood